Alrighty, good stuff. So, a little bit about me. My name is Josh Long. So nice to meet you all. Thank you so much for joining us today. Obviously, we have a lot to cover in very little time. So, briefly, here are the important bits. This is my online coordinates. Should you have questions, comments, feedback, whatever, don't hesitate to reach me there. I'm happy to answer questions. In addition, there's code down there at the github.com reactive-revolution URI. I work on the Spring team. I've got some training videos on live lessons on Safari. I've got a book called Cloud Native Java that I wrote a couple of years ago. I've got a podcast called A Beautiful Podcast, which is just me talking to people that are smarter than I am about all sorts of different stuff. I have a screencast that I do every Tuesday called This Week in Spring. I have a screencast series called Spring Tips, which I do every Wednesday on YouTube. And I have a new book that just got released. It's no longer, it's just out, my new book. There you go. Okay, right. So you can get that as well. reactivespring.io, and you can find it there on LeanPub and Amazon and so on. So it's there. And of course, I'm happy to be here. Now we're going to talk about reactive programming. To appreciate why we care about reactive programming, we need to sort of consider the circumstances that motivate the use of reactive programming. Now, reactive programming is not a new idea by any stretch, right? Obviously, there have been plenty of people who have tried to build software that is more efficient. But reactive programming is, I think, a fairly unique solution to a problem that a lot of us have had, which is that software, as written in traditional styles using the Java JVM, can be very inefficient. And one of the reasons for this inefficiency is more pronounced, it's more obvious in the face of microservices. So when we move to a microservices organization and to a structure, we are building services and software that take advantage of network input and output. And there we see lots of resource inefficiency, right? That scalability limitation. So this is part one. This is the first problem. The second problem is, of course, is that now that we have moved to microservices, we are doing more and more things over the network. This is distribution. This involves volatility, right? This volatility makes it difficult for us to guarantee that things will go the way that we expect when we build distributed systems. And so we need something that gives us the tool set to deal with these problems. And so this is where reactive programming comes into play right now. I just realized I'm on the wrong desktop, friends. Let's go here. See, much better. Now, what we're going to do is we're going to take advantage of the support in Spring to address both of these concerns. And we're going to go pretty quickly here. So let's just get started. We're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production, but my second favorite place is start.spring.io. And we're going to build a brand new application here using just the default settings there. Now, there's obviously a lot of things that we could look at, right? Obviously, I'm using 2.3.0 or 2.3.3. This is a new version of Spring Boot. There's some amazing things that come in there out of the box, including easy Docker image creation. You just say maven-spring-boot, maven spring, come on, mvn spring hyphen boot build on image. There you go, right? You can do that. And then I'll give you a Docker image. That's pretty cool. One of my favorite features in the new Spring Boot support is, especially when you're using 2.4.0, the milestones, you have the ability to build native images using GraalVM. So this support here is really compelling, right? So it makes it even easier to build more cloud native applications. Now, obviously, Spring Boot is perfect for the cloud. It always has been. That's why I wrote that book 3 years ago called Cloud Native Java. It is a natural fit in the cloud. It has the best integration for building dynamic cloud-ready services. But now, we can even go further. We can actually reduce the footprint even more by using these GraalVM compilations. So, for example, if I go to here, there you go. Code. Okay, this is fine. I name Graal. Oops. Yeah. Okay. You can see I've got a number of different versions of an application here. I've got a traditional application. This traditional application uses, you know, Spring MVC, serverless API, Hibernate, and all that stuff, right? So it's not it's not the fastest application. Oh, I don't have that compiled here. Let's go here then to the reactive one. CD. Oh yeah, okay. So wait, did I have that there? I think I did. Yeah, there you go, traditional. So if I run this one, whoops. There you go. If I run that one, it's you know, it's up and running. Go here, localhost 8080, and I think it's called customers, right? This is a customer's endpoint. Oh. Okay, what is going on? Is it some other endpoint that I have? There you go. That's what it was. That's that endpoint. So you have the ability to create really, really fast services, even for the most inefficient of stacks, right? Even for the ones that don't particularly perform very well. When you go to the efficient stacks, like the reactive stuff, oh my goodness, you know, the opportunities are endless, right? So this is, let's see, there you go, 0.131. And now, actually, this is an old version of the GraalVM feature. Nowadays, most of my applications start up in less than 1/10 of a second. So really, really amazing opportunities there. That's not what we're going to talk about. It's not why we're here. I just wanted to mention it. You should definitely check out Spring GraalVM 0.8, you know, 0.8, I think so. This one, 0.8, right? So look at the guide for that, and you can see how to do it for yourself, right? You can see how it applies to your applications. But we don't have time for that. What we're going to talk about is reactive applications. So we're going to build an app. This is the reactive web support. We're going to use R2VC, which is a PostgreSQL, you know, it's a SQL database abstraction for reactive applications. We're going to use Lumbuck. We're going to use RSocket. And I think that's it. I think I'm happy with that selection now. So we're going to go ahead and hit generate, and that'll give us a new service, which I'm going to then open up in my IDE. So I've got my IDE here, UAO service.zip. Okay, it's still downloading the internet for some reason. Oh, it's right after midnight. That's what it is, friends. It's right after midnight, of course, new stuff. Okay, so here's our service application. Our application is just going to be an application that writes data to the database. So as usual, I like to start this process by creating something that we can write to a database. I'm going to create a regular POJO that we're going to, you know, persist to the database as usual. It's going to be an ID, so private string, a private integer ID, and private string name, right? So at ID. And that'll be the basic POJO. And I'm going to create a reservation repository. Extends a reactive CRUD repository. Now this is just a thing that we're going to write to the database using this data access tier code called a repository. Now the repository in turn has several methods that are I think they're going to be pretty familiar if you've ever used Spring Data. So I don't need to explain what save and save all and all that does. But what might be interesting is this, the publisher. A publisher is a reactive stream type that publishes data asynchronously to a consumer. The publisher, when it first is created, is then made available for subscribers, which then subscribe to it. The subscribers can subscribe to the publisher, and when they do, they are given a reference to a subscription. This is the most important part, okay? We'll talk about that in just a second. When the publisher sends data to the subscribers, it arrives in the onNext method. When there are errors, it arrives in the onError method. And when we're done processing the data, that happens in the onComplete method. So this subscription is what the subscriber uses to ask for more data or to cancel the stream of data. That's called back pressure or flow control, and it's not a new idea. Now, these three types are very simple. There's a fourth one called processor, which is a bridge, it's a source and a sink, and they're part of the reactive streams effort, part of the effort done by the Spring team, by Lightbend, by Netflix, by the Eclipse Foundation to build a better component model for building reactive applications. This was done years ago, and it's now actually such a useful thing. It's so common, in fact, that it's now part of Java 9. So you can see Java util concurrent flow dot processor dot subscription dot subscriber, etc. So these are the same types with different packages, and they're interchangeable. There's adapter types you can use. Now they're very simple, and people want operators. They want things to use to be able to flat map and filter and so on. And so we have two subtypes, two specializations. The first is a mono. A mono is a publisher. It produces 0 or 1 value. The other type that we have is a flux. A flux is a publisher as well. It produces 0, 1, 2, 5, 10, a trillion, a billion, or infinite values, right? So it is also a publisher, and they have different semantics, but they're both publishers. And so we can use these to write data to the database, okay? So we're gonna write a sample data initializer. And what I'm gonna do here is I'm going to take some names from people in the Spring team, and I'll use this to write their names to the database, right? So public void begin, and we're going to say private final reservation repository, and we're just going to inject the repository, okay? Now I want to inject this into the constructor. I could write the constructor myself, right? Like to use Lombok, so I'll say, oops, say flux.just, and let's see who's on the Spring team. Madura is on the Spring team. Olga, she's on the Spring team too. Violetta, we've got her on the Spring team. We've got Yushin. Okay, we've got her. We've got who else is on the Spring team? Dr. Sire, right? We've got him. We've got Stefan. We've got me. We've got Spencer. There you go. There's 8 people on the Spring team. And what we're going to do is we're going to visit each name and turn it into a new reservation. So null name. And for each name that for each reservation that we create, we want to save it to the database. So I'm going to say map r this.reservation repository.save. And you can see we've got a problem here, right? If you look at the return value for save, I get a mono of s, right? So map takes the lambda and it accumulates it into a container type. So I get flux mono reservation. I don't want both. I just want one. I want to get one view like that. So in order to do that, you need to use flat map, right? So flat map unpacks, or it flattens the reactive stream. Now, if I run this code right now like it is, nothing is going to happen. In order for reactive streams to start, you need to subscribe, okay? So there you go. There's my subscription. And if I run this code, I'll see the actual data written to the database. But the problem is, of course, that this is a lot of code, first of all. So let's clean it up. I like to use chaining to clean things up a little bit. And then second of all, we don't have any care here about what happens if the code is executed multiple times. I'll get 8 records and then 16 and then 24 and so on. So what I want to do is I want to delete the data in the repository first, and then I want to write the data, and then I want to find the results. So I'll say this.reservation repository.delete all, right? And then I'll say write the data, and then finally I'll ask for the data to come back, right? And finally I'll just log out all of it, like so, system out print line. Okay. So there you go. There's my reactive pipeline, the whole thing, and that'll give me the result I'm expecting, right? So let's run this and see what we get. Okay, it's saying, hey, we need a database, and that's true. So we're going to use a SQL abstraction. Now we can use Spring Data, and we can use the reactive Spring Data modules. There's a lot of different modules here that support what we're trying to do. But for SQL access, for SQL-based database access, a very common question we get is, can we do that? And of course, we can't use JDBC, right? JDBC builds upon the blocking and synchronous, Java I/O input stream and output stream. So we need something that is non-blocking, something that allows us to scale. So we created something called R2DBC. It's kind of like JDBC, but it's reactive. And there are a number of different drivers for PostgreSQL, MySQL, MariaDB, SAP HANA, Microsoft SQL Server, and a bunch of H2, Oracle have even said that they're doing a version as well. So there's a number of different versions out there that you can look at. And we also have Spring Data R2DBC. So that's what's allowing us to make it very easy to create data access code that talks to a database with an ORM using reactive APIs. Okay, so now if I run this again, okay, take two, what do we got? Unable to create a it's my configuration, my properties here. R2DBC, localhost, PostgreSQL. Is it? I never remember. What's the issue here? R2DBC, 2DBC. Oh, I forgot to add a Postgres driver implementation. So Postgres Explorer, that's what this is. Okay, no problem. So we need to take the Postgres implementation, add that to the build, and go. Okay, so there's data in the database. We can see that we got a UUID as well, so that's working as well. So good, that's fine, right? Now, what I want to do is I want to build an HTTP endpoint, and this is easy. I could build a REST controller, or I could use the functional reactive style. So I could say router function, server response, like so, HTTP, turn build .get /reservations request server response .ok .body. All right, and what I'm going to do is I'm going to inject my reservation repository there. rr.find all reservation class. Okay. So there's my reactive stream. And what I want to do with that is just show you the HTTP endpoint. So let's go ahead and restart this. Go to the browser and wait for the compilation to happen. Okay, localhost reservations. There's our data in the database. So that's working just fine. But again, this is not very impressive, right? You have used SQL and web technologies for years. You could have done this yesterday, right? This is not something you need reactive APIs for. And that's my point. I'm not trying to convince you that right now reactive programming is very different. I'm trying to convince you that it's actually, for a lot of the code, very similar to what you would have done before. This looks and feels very similar. And so what I'm trying to say is you can do the things that you were doing before with the same ease, with the same code complexity, right? And that's actually a very interesting situation to be in. It doesn't take more code or more brains to understand the code to get this to work, right? If you look at the code that we've written, obviously all of this is just for the demo, right? This is just for our demonstration. So really, it's just a repository and an entity and this, right? That's our entire application: data access, web access, and so on. So what you see now is that we have parity, we have equality with what we had before. I can do the same things as I could do before, but now it's much more efficient. And actually, we get something else from this. Excuse me. We get something else from this. We get consistency. This is an important part here. So what you're going to find is that when you use reactive APIs, yeah, they look a little different, right? Flux.just and all that, but these reactive APIs are not that different compared to, say, for example, the Java 8 Streams API. And once you've learned them, then you only have to know the reactive Streams APIs. Suddenly, everything else becomes reactive Streams. So imagine if you wanted to do WebSockets, you use reactive streams. If you wanted to do RSocket, you use reactive streams. If you want to do HTTP, you use reactive streams. You want to do SQL, reactive streams. NoSQL, reactive streams. You want to do Kafka, reactive streams. RabbitMQ, reactive streams, etc., etc., etc. It's one API, and that's the power of this. Whether you're representing something that you would have thought of as a collection before, if you're representing something that is an asynchronous thing, there's no two different APIs. If you want to say, hey, I've got some data coming in the future, but it's not here right now, then you use a reactive stream. If you want to say, I've got something that has just a little bit of records, a little bit of data, and it's all here right now, you also use a reactive stream. Your life becomes very consistent, very simple when you use reactive programming. So already we are ahead compared to where we were before, but we haven't even really seen where reactive programming is most powerful. It offers two benefits that I think are pretty hard to ignore. The first is that it is much more efficient especially when you have situations where you have the risk of keeping a thread open in the non-reactive world. So imagine you're building a web service where you have chat notifications or stock tickers or anything like this. Anything where the client wants to get immediate updates from the service. It's very important in this case that the client be connected all the time. In a traditional application, this would require that you keep a thread on the server allocated or assigned to the client. Well, now we can change that. We can say, okay, we're going to use asynchronous I/O, and we're going to use reactive streams. This will give us a way to have data that we produce that occupies a thread for as long as it needs to, but then it jumps off of the thread and frees up the thread for something else in the system to reuse. So let's look at an example of something that would require this long-running kind of thread in the old world that we can make much easier in the new world, right? So we're going to say WebSocket configuration, and we're going to create a simple URL handler mapping. And what we're doing is we're going to create a new WebSocket endpoint. But WebSockets are a binary protocol that you have to connect to using HTTP. So you have a handler, and the handler is used to update the client from HTTP to the binary WebSocket protocol. So that's what I've just done here. As I've said, when a client connects to WS Greetings, upgrade them to the WebSocket handler. Now, we're going to write that WebSocket handler in just 1 second. We'll do this together, right? That'll be the business logic. And the other thing that we need is a WebSocket handler adapter. Okay, so an adapter just to tell Spring to look for these components in the container. All right, so now the WebSocket handler is a pretty straightforward interface, right? You are given a session, and the client can send data to the service via the session. So you can say, hey, I've got a WebSocket message. Let's get the payload as text. And then I want to take that payload, and then for each message, I want to take the string that's coming in from the client and turn it into a greetings, okay? So I'm going to have a greetings service, okay? Greeting service. And this service will expect greetings requests, and it'll produce a stream of greetings response. So here's the response, here's the name that's going to come in the request. These are just DTOs, right? We don't need to worry about them too much. So let's take these annotations here. And what I'm going to do is I'm going to go down and I'm going to create a very simple service just to demonstrate a never-ending stream of data. Okay, so we're going to create a greetings response when somebody sends us a greetings request. We're going to say return flux.fromStream, stream.generate new supplier, and we're going to produce a new greetings response. Hello, request.getName at instant dot instant dot now. Okay, there we are. So there's our stream. And, well, hey, come on, instant. I need Turkish coffee. That way I would be more awake. There we go. So there's this. And I could then slow that down a little bit so that we can see what's happening. So what I will do is at the end here, I will say I want to delay the elements by 1 second. So every new value will be slowed down by 1 second. That way we can see what's happening. I'm going to use this service here in the WebSocket handler. So I'll inject that here. I'll say greetings service. Okay, I'm going to use the greetings service, and we'll say, okay, when we get a new name, turn it into a greetings request. And then for each name, for each greetings request, we're going to call the service. We're going to say flat map greetings service dot greet gr. Okay, there's this. And then for each one of those message, this is the response. For each one of those, we're going to turn it into a WebSocket text message like so. And that'll give us, we have to, for each one of those, we need to unpack the greetings response dot get name. Did I do that wrong? Where's my service here? Greetings response looks correct. This is message. That's what the issue is. Okay, there we go. So get message. And once we have the message, then we'll just take the whole thing, and that'll give us a stream of WebSocket messages. Now that's the entire application. That's the entire chat, if you will. That's the entire interaction. Now I'm going to send this. I'll say session.send map. Now, obviously, this is just a server-side implementation of WebSockets. I want to demonstrate that this is working, so I need to do something to demonstrate the client perspective. And I don't know of a more efficient, more elegant way to do this, unfortunately. So I feel like I must do something, but I'm not very proud of this. I wish that there was some other way to do this. What I'm going to do is something terrible, something that I would never do in polite company if I could find some other way. I am going to write JavaScript. Okay, so here we go. ws.html, HTML, and we'll say body script const ws equals new WebSocket localhost 8080/ws greetings ws.add event listener message. Good. Okay, there's that, and add open. So what I'm going to do is I'm going to say when the socket first connects, I care about the connect event, right? I care about that, and I'm going to use that as a chance to make a request to the WebSocket. So I'll say Istanbul. There you go. Okay, so it's a name that we're sending, and we're going to log out the results. We're going to say new message, and here's the message that we're going to receive. So message.data. Okay, there's our entire reactive stream, entire situation. Now, I'm going to run this application again, and we'll see it in action. Localhost. Is it compiled yet? Good. It's up. ws.html. Now, there's our never-ending stream, and it's going to keep going on forever and ever and ever. That's okay, because it's not going to block the threads, right? It's going to free up the thread each time, and that allows us to have much better scalability. I can handle many, 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 many more users with the same code base. This is one benefit of reactive programming. The other benefit is that it is very easy to build elegant service orchestration and composition with reactive streams. So what I'm going to do now is I'm going to build a client that will talk to our service. Now, I have a HTTP endpoint and I have a WebSocket endpoint, but how would I communicate from one Java service to another? I guess I could use WebSockets, right? WebSockets are one option, but they're a binary protocol. They don't have headers. That makes it very difficult to do on the wire, in the message frame authentication, right? How do you send out-of-band information like a header? Like a token, right? If you don't have headers. So that's one problem. HTTP is certainly not a good fit for microservice communication, right? It's okay, but there's a lot of issues. Google tried to fix a lot of those issues by creating gRPC, but of course, this is still tied to HTTP2, which is only request response. And It's also code generation, and it's also Google protocol buffs. So you're very constrained in what you can do there. Facebook decided to solve this problem, and they created something called RSocket. Now, RSocket is a binary protocol. It is language and platform agnostic, so it doesn't matter which technologies you use to talk to it. It's a protocol. It's a wire protocol. There are many different client implementations in Java, C++, JavaScript, Go, etc. The protocol is natively reactive on the wire, so it understands this concept of back pressure. That is, a client in the reactive APIs can ask a service to slow down, which you cannot do with HTTP, right? With HTTP, as soon as the client starts sending the data, the service starts sending the data, it just has to continue, right? There's no way to like pause. So this is very interesting. The other thing that's very interesting about RSocket is that it gives you full control over what payloads you send on the wire. You can use JSON or XML or CBOR or binary data, Google protocol buffers, anything you want. It's anything, right? It doesn't care. The other thing is that there's no code generation. It's just a messaging protocol after all. The other thing that's very interesting is that it supports many different message exchange patterns. So request response is very common in HTTP, since that's the only one that you have. In RSocket, you can do request response. You can do request and a stream. Which you can kind of simulate. You can kind of approximate that with HTTP, to be fair. We also have fire and forget. So you can say, here's some data, and then I don't care about the response, right? You send a request, but you don't get the response because you don't care. It's just a broadcast kind of thing. So there are lots of examples of like telemetry or heartbeats or whatever, where if you lose a record or two, it doesn't matter. You're just trying to make sure that you emit the results, okay? That's very common. And the other thing is it can also do full bidirectional streaming. The other thing that's very interesting about RSocket is that it's it supports a stateful connection. So once the client and the service connect, they are connected, and they're no longer client and service, because at that point, either side can send a message to the other side. So and really, at that point, they're just two sockets that are talking to each other, and either one can make as many ask as many questions as it wants from the other side. We call them requester responder. Now, it's very easy to take a service or to build an RSocket service in Spring. So I have our controller. I have the service here. I'm going to turn this into an RSocket controller, like so. At message mapping, greetings. I'll go to my property file and I'll say RSocket server port equals 8888, and that's it, right? I've created this endpoint, and it now will be available for somebody to consume from port 8888. And of course, I could use the very convenient RSocket client. I could say RSC, minus R is greetings, and then provide the TCP localhost 8888, okay? And I could say that the data that I want to send in is a Java object with a name and a string. So name will be Istanbul, okay? And I can say that I want a stream of results back. 8888, did I not do that wrong? Right? Localhost stream, what endpoint did I call it? Greetings. It's on port 8888. Greetings. RSC. And it's a stream. Oh, it's okay. Just have to go over there. Oh, but I have forgotten the syntax there. Doesn't matter. That's one way to talk to it. The other is you can create a client. So I have a client here. I go to my client and open it up, okay, as usual. And in the meantime, github.com mocking RSC, route. It's could have sworn it's this. Did I? Oh well. Localhost 8888. I'm missing something very obvious here, my friends. Doesn't matter. Okay, so anyway, we have a client now, and in the client, I'm going to connect via Java to the RSocket code. So client, and here, I'll just create a bean of type RSocket requester .builder, turn builder dot connect TCP localhost 8888. Now this is a very interesting protocol. Facebook, it was built at Netflix, and it was then moved. You know, the engineers that worked on it eventually went to Facebook, and so it's a protocol that was built by people in production, right? Very, very important there. The Java client was built using Project Reactor, which is the API that powers all the reactive stuff that we've seen so far. So it's very mature, right? Very, very useful. And I can very easily, you see, we have now a component model in Spring that makes it easy for me to build services declaratively using the add controller annotations and so on. So very, very powerful API. It's all open source, and it's also now the first project that the Spring team and Alibaba and Facebook and others donated to the new Reactive Foundation, which we are all founders of, right? So very, very powerful protocol. It's the first thing that we donated to that foundation that we're working on together. The future for it is amazing, right? It's being used by Facebook. It's being used by Alibaba. It's being used by large organizations all around the world. And I hope you'll give it a shot. Okay, subscribe, system out, print line. Okay, client application. What did I do wrong? Oh, port 8080, so of course. It thinks that we want a HTTP port. I don't. I just want a random one. There you go, my friends. You can see on the bottom, it's showing us new results every second, and that's okay because again, it's not going to keep it's not going to block the threads when it does that. All right, my friends, we've only just begun. We haven't even looked at everything yet, but we are, I'm afraid, out of time. I hope that you got something out of this. We looked at reactive APIs, we looked at data access, we looked at building reactive HTTP endpoints, we looked at WebSockets, and then we looked at a very exciting, very powerful new technology called RSocket. I hope you learned something from this. I hope you'll find me on Twitter. I'm at StarbucksMan. My email is josh@joshlang.com. Maybe look at my book if you want to learn more about this, or just send me an email, or just watch this video again. Doesn't matter. I'm happy to help. Thank you so much for your time. I hope you're all healthy and happy, and I hope next year we can meet each other again safely in person. Teshakur, everybody. Thank you so much.